Hello students! Welcome back to Mathematics Online Lesson Class with Ma'am Lorena S. Maglonso. So for today, we're going to discuss Mathematics Quarter 1, Module 5A, Multiplying and Dividing Rational Algebraic Expressions. The module is divided into the following lesson. For Lesson 1, we have Multiplying Rational Algebraic Expressions. Lesson 2, Dividing Rational Algebraic Expressions. And in going through this module, you are expected to 1. Multiply rational algebraic expressions and 2. Divide rational algebraic expressions. So before we proceed in the discussion, let's have a short review. So match the expressions in column A with its product in column B. So for number 1, for column A, we have 4 over 3 times 5 over 7. What is your answer? If your answer is B, 20 over 21, very good, you are correct. Next, number 2. We have 2 over 5 times 3 over 2. What is your answer? If your answer is letter C, 3 over 5, you are correct. Next, number 3. We have 5 over 10 times 2 over 6. The answer is very good. That is letter A, 1 over 6. Next, number 4. We have 3 over 9 times 12 over 15. What is your answer? Very good. The correct answer is letter E, 4 over 15. And last, number 5. We have 3 over 5 times 3. What is your answer? Is it letter D or letter F? If your answer is letter D, you're right. That is 9 over 5. Now, the question is, how did you get the answers in column A? If you're going to recall how to multiply fractions, the answer is you're going to multiply the numerator by numerator and multiply the denominator by the denominator. And then simply simplify. Today, we're going to discuss multiplying rational algebraic expressions. So let's have an example. So multiply 37x over 2y times y over 4. So there are two methods in multiplying rational algebraic expression. In this example, we're going to use the method 1, which is divide out the greatest common monomial factor, or the Gcmf, after multiplying. So how does it goes? So for step 1, multiply the numerators and denominators of the given rational algebraic expressions. So first is multiply the numerators. So for 37x over 2y, so numerator is 37x times y is equal to 37xy. Next is multiply the denominators. So 2y times 4 is equal to 8y. Next is step 2, find the Gcmf of the product of numerators and denominators. So we're going to look for prime factors. For 37xy, the prime factors are 37 times x times y. While for the 8y, we have 2 times 2 times 2 times y. And then we're going now to look for the common factors from the two groups of factors. So we're now going to look for the common factors. So here, we have here the common factor, which is y. And that will be our GCF. So the GCF is y. After that, step 3, divide out the GCMF of the product of numerators and denominators. So for this 37x over 2y times y over 4, that is the given, it will become now 37xy times 8y when we multiply the numerator by numerator over denominator times denominator. So with that, the products are not yet reduced. So we're going divide out the GCMF, which is y. So this will become like this. So this will become cancelled because that is the GCMF. Now simplify the remaining factors. So the remaining factors will now be 37x over 8. And that is the product in reduced form. This is now the final answer. Next is example 2. Multiply 15y over 2y times 2y over 5x squared. This time, we're now going to use method 2, which is divide out greatest common monomial factor or the Gcmf before multiplying. So, the first one is after multiplying now. This time, before multiplying, we're now going to divide out the Gcmf. So, first is find the Gcmf of numerators and denominators. So, look for prime factors of the two numerators. So, for 15y and 2y, the Gcmf is 3 times 5 times y times 2 times y. This is the prime factors only. While the prime factors for the two denominators, so for 2y times 5x squared, the prime factors are 2 times y times 5 times x times x. And then we're now going to look for common factors from the numerators and denominators. So the common factors are, we have here 5, y, and 2. So with that, we're now going GCMF, or the GCF is 2 times y times 5. Or we can, this can be rumble. So, pwedeng mauna yung y, say 2 sa 5, nauna si 5 kay y sa 2. As long as that is 2y and 5. Next is, we're now going to divide out the GCMF of the numerators and denominators. So, using 2y, 5. So, 15y over 2y times 2y over 5x squared is equal, that is equal to 3 times 5 times y. This is the prime factors. 2 times y all over 2 times y times 5 times x times x. So, this is the factorization of the numerators and the denominators. Now, we're going to divide out the GCMF. So, this is a long method. So, divide. So, if we're going to divide, we're going to divide y, and then 2. Then, simplify the remaining factors. So, the remaining factors are 3 and y in the numerator, and in the denominator, we have 1, x, and x. Then, we're multiplying the numerators. That is 3 times y over 3 over 1 times 1, y over x times x. So, multiply the numerators, multiply the denominators. The final answer will become 3y over x squared. And this is the product in reduced form. So, this is the long method. Now, let's multiply x squared minus 4 over 2 times 4 over x minus 2. So, this time, we're going to solve this without the solution or the method that we have used. So, for here, we have x squared minus 4 all over 2 times 4 over x minus 2. The method that I'm going to use is factor first, the numerator, and then denominator, and then we're now going to cancel the common factors. For x squared minus 4, this is a difference of 2 squares, so we have x plus 2 times the quantity of x minus 2 all over 2. While for 4, the factors are 2 times 2, and then copy x minus 2. Now, we're now going to cancel the common factors. Again, common factors, not common terms. The common factors, here we have x minus 2, and then 2. Now, let's multiply the remaining factors. The remaining factors in the numerator, we have 2 times x plus 2. I'm just going to write first 2. And in the denominator, we don't have anything left. So, this is now the final answer. Next, how about x minus 5 over x squared minus 7x plus 10 times x squared plus x minus 6 over 5. So, I'm going to copy first the given. So, I'm going to use again the same procedure I made in example number 3, which is I factor first the numerator and the denominator, and then cancel the common factors. So, for x minus 5, that is in simplest form. So, it will remain x minus 5. While x squared minus 7x plus 10, this is an example of general trinomials. So, I'll think of a number that when I multiply is positive 10, but when I added is negative 7. And that is negative 5 and negative 2. Next, for x squared plus x minus 6, this is also example of general trinomials. So I'm going to think of two numbers that when I multiply is negative 6 and when I added is positive 3. And that is positive 3 and positive, oh no, not positive, negative. Because the last term is negative 6. So that is negative 2. And 5, it will remain 5. Now, I can now cancel the common factors. We have here common factors x minus 5 and then x minus 2. So, we're now going to get the remaining factors in the numerator and the denominator. So, in the numerator, we have x plus 3 and in the denominator, we have 5. And this is the final answer. So don't forget, in multiplying rational algebraic expressions, either before or after multiplying, always divide out the common factors to attain the product in reduced form. So let's now proceed to dividing rational algebraic expression. So let's have a short review. So match again expressions in column A with quotients in column B. So for column A, number 1, we have 4 over 3 divided by 5 over 7. What is your answer? Okay, the correct answer is letter F, that is 28 over 15. Next, number 2, 2 over 5 divided by 2 over 3. What is your answer? The answer will become 3 over 5. Very good. For number 3, we have 6 divided by 6 over 2. The answer is letter B, correct? That is 2. For number 4, we have 3 over 7 divided by 4. The answer is letter C, 3 over 28. And for number 5, we have 3 over 5 divided by 3 over 5. The answer is letter D, 1. So how did you get the quotient in dividing fractions? Okay, if you're going to recall, we get the reciprocal of the divisor. So ano ba yung reciprocal? When we say reciprocal, that is, we're going to put the denominator in the numerator and the numerator into the denominator. So, the quotient of two rational algebraic expressions is the product of the dividend and the reciprocal of the divisor. So, in symbols, we have A over B divided by C over D is equal to A over B times D over C is equal to AD over BC. BCD is not equal to 0. So, after going the reciprocal of the divisor, you're going now to proceed to multiplication of rational algebraic expressions. So, let's have an example. So, x plus y over x minus y divided by x over y. So, first, let's identify the dividend and the divisor. In here, the dividend is, determine the dividend and divisor of the expression. So here, x plus y over x minus y divided by x over y. X plus y over x minus y is the dividend. So obviously, x over y is the divisor. Now, we're going to find the reciprocal of the divisor. So reciprocal means its multiplicative inverse. So x over y will now become y over x. Then, after that, step 3, multiply the dividend with the reciprocal of the divisor. So, x plus y over x minus y divided by x over y. So, multiply numerator with numerator. So, this will become x plus y over x minus y times y over x. So, if you're going to take a look, this is the divisor in the given. Now, when you get the reciprocal, that is y over x. And then the division sign, it now will become multiplication sign. Next is multiply denominator with the denominator. So that's it you're going to do. So using distributive property, we'll now have for x plus y, the quantity of x plus y times y, we'll now have x times y plus y times y. And then for the denominator, we're now going to have x times x minus y times x. So, when we multiply x times y, that is xy, y times y is y squared, x times x is x squared, minus y times x is xy. And this is the quotient in reduced form. So this is now the final answer. Okay, let's have another example. We have 3p squared plus 6p plus 3 over p plus 1 divided by 3 over p. So let's identify the dividend and the divisor. This is the dividend and this is the divisor, which we're going to get the reciprocal. So the reciprocal is reciprocal of the divisor. That will become p over 3. So we're now going to rewrite 3p squared plus 6p plus 3 all over p plus 1 times p over 3. Now, we're going to factor first the numerator, which is 3p squared plus 6p plus 3. So, I'm going to use the slide divide bottoms up to get the factors. So, first, slide 3 to the last term, which is 3, or multiply. The answer will become 9. Then, bring down p squared plus 6p. Plus, instead of 3, we're now going to use 9. And then we're now going to factor this. Oh no, this is a example of a perfect square trinomial. No, this is a general trinomial. So, p plus p. So, think of a numbers that when you multiply is 3. When you multiply the two numbers is 9. And when you added is 6. So, that is 3 and 3. 3 times 3 is 9. 3 plus 3 is 6. Now, bring down the numerical coefficient of the first term of the given. So, let's divide this by 3. Then, reduce to lowest term. We have now p plus 1 over p plus 1. Oh, this is also a perfect square trinomial, rather. So, this is now the factors of the 3p squared. Oh, I think there is something wrong here. Oh, before we get the factors of this, we're not going to use this. We're going to use the greatest common monomial factor because we have here 3, 6, and 3. Okay, sorry. Why am I wrong? My fault. Okay, get first the Gcmf. So the Gcmf here is 3. So we have here p squared plus 6p divided by 3 is 2p plus 1. So we're now going to this one, factor this. So we have p plus 1 and then p plus 1. 1 times 1 is 1, 1 plus 1 is 2. So this will become the factors of 3p squared plus 6p plus 3. So we have here 3 and then p plus 1, p plus 1 all over p plus 1 times p over 3. So cancel the common factor. We have 3 and then p plus 1. Now the remaining factors, we have p times p plus 1 and that is the final answer. So again, before you proceed to any factoring, don't forget to check first if there is a greatest common monomial factor. Like me, I forgot to check first the greatest common monomial factor. And that's it for example number 1. That's example number 2. So this is example number 3. So divide x squared plus 5x plus 6 over x squared plus 4x plus 4 divided by x plus 1 over x plus 3. So copy x squared plus 5x plus 6 over x squared plus 4x plus 4. Then, this is the dividend and this is the divisor. So, division sign, change to multiplication sign. Then, get the reciprocal of the divisor. So, that will become x plus 3 over x plus 1. Then, to factor x squared plus 5x plus 6. So, we don't have common factors. Ayan. So, we can now proceed to factoring this using general trinomial factors. So, we're going to think of two numbers that when you multiply is positive, 6, and then when you added is 5. That is x plus 3 and x plus 2. Next, for x squared plus 4x plus 4, so we have there x plus 2 times the quantity of x plus 2. So, 2 times 2 is 4, 2 plus 2 is 4. Then, copy x plus 3 and x plus 1. Then we can now proceed to the cancellation of common factors. So we have here x plus 2 and then that's only x plus 2. We cannot cancel x plus 3 because they are both in the numerator. So the remaining factors are x plus 3 times x plus 3 over x plus 2 times the quantity of x plus 1. And this is the final answer. And that's it. Thank you for watching. Have a great day. Bye.